Okay, that was a little eerie. Makes you think this is a little bit difficult, but it's actually not. You're going to be fine as long as you follow one rule, and that's base times height for area of a rectangle and pi r squared of area of a circle. What you have to do here is you're going to have to put a couple of things together. And so area of a composite shape is a shape that can be broken down and needs to be broken down into two parts. So if I look at, say, this question, Felicity recently moved into a house and she's building herself some hardwood floor, and here's a sketch of the diagram. Well, I've got two triangles or two rectangles here, and I could break this up this way and say, okay, there's triangle 1 and there's triangle 2, or triangle, cripes almighty, rectangles. I could break it up into two rectangles, or, let's just erase that. I'm going to break it up this way. Oops, I need that marker. I'm going to break it up this way. For no other reason, that's just what I'm going to call that area 1 and that area 2. So there's one rectangle and there's the other rectangle. Okay, and this is actually a square. So the area of this plus the area of this. So if I take this area of 1 and add it to the area of the second, that'll tell me the area of the total amount. And the calculations are so simple. I'm not going to work through it here with you, but here they are. Come on, there we are. Close that and delete. So there it is. Area of the first first rectangle was 12 by 12, which gives me 144. The area of the second was 12 by 18, which gives me 252. When I added those two numbers together, I got area was 396 square feet. So pretty simple stuff. You just got to plan ahead a little bit when you're doing some of the questions. Here's another one. I took a picture of it and it's blurry as all get up, so sorry about that. But calculate the area of this composite shape. Well, if I look here, I could figure out the area of, call that 1 and this 2. The problem here is that I haven't been given all the information. I don't know what this side is right here. But I do know the length of that is 9 and the length of this is 6. So what's left for this piece right here, which we'll now draw in yellow, what's left for there would be 9 subtract 6, which would make this 3. So the area of this piece here is 2 times 3, which is 6. And then the area of this would be 6 by this. Now this, I don't know. So it's going to be 6 times something. Now I do know that this piece here was 2 feet, and this piece here is 3 feet. So together, this side must be 5 feet. So this is going to be 6 times 5, which gives me 30. So I have 6 plus 30, which is 36 square feet. Like so. Okay. It says use a second strategy to verify your answer. Well, you could break it up this way and call this rectangle 1 and this one down here rectangle 2, but I'm not going to do that. All right. So pretty regular stuff. I want you to try page 144, questions 1 to 6, under the Try It section. And again, this would be a good place to pause this video so you can work on those questions and then go to the next section. The next section deals with dimensions and enlarging things and changing the dimensions of something. So Ryan had his picture taken, and the picture measured 20 by 10 centimeters. So what's the area of the photo is 20 times 10, which is going to be 200 square centimeters. Like so. Squared. His parents decided to have the photo enlarged and mounted on a plaque. They asked to enlarge it to double both the width and the height of the photo. So the question is, what is the area? What is the new area? Well, the trouble with this is, the easiest thing to do is say it's, well, 400, but it's not 400. It's going to be 800, because I'm going to double that, so it's going to be 40, and I'm going to double that, which is 20, which gives me an area of 800 square centimeters. Okay. How many times as large as the area of the original photo is the enlargement? Well, it's going to be 4 times bigger. And the reason it's 4 times bigger is because this is 2 times bigger, and this is 2 times bigger, and so you've got 2 times and 2 times. So that's why you get an area that is 4 times bigger than the original. Suppose the dimensions were multiplied by 4 instead of 2. How would the area look? Well, it would be, let's call that, I'm going to multiply that by 4, so that would be, let's put this in yellow. That would be 4 times 20 is 80, and this piece right here would be 4 times that, which is 40, which when I multiply that would be 3,200 square centimeters. Big picture. Which when I compare it to the original, it is going to be 16 times bigger. And it would be 16 times bigger because you'd go 4 times the length and 4 times the width, and 4 times 4 is 16. So you get something 16 times bigger. And if you're looking for visual effects, at the bottom of page 146 is a good indicator of why that works. So we're going to skip over to page 150 in your booklet, and we're going to work on questions 1 to 4. Okay? Now, once you get those questions done, you need to check the next page. Because there's where your assignment comes in. All right? So here's your backyard assignment that we talked about the other day in class, and I would pause the video here to make sure you read the instructions. You're going to produce an architect design, basically a blueprint of your dream backyard. Your backyard is going to be, see you later, have a good night. Okay, that sounds good, thanks Don. Your yard is going to be 120 feet by 100 feet. So you're going to draw it to a scale of 1 centimeter equals 5 feet. That will fit on a basic 8.5 by 11 piece of paper. So your basic white blank piece of paper it'll fit on. You have to have in your drawing in your backyard a pool, a deck that's attached to the house. Something like this should be shown. Trees and bushes, and at least 3 other things. Whatever you want. Your imagination's the only thing holding you back. Everything needs to be drawn to scale. And then I need on a separate piece of paper a list of the dimensions of each item. Okay? So you're going to draw that, and if you're not sure exactly what I'm talking about, or you still haven't really pictured anything in your mind, the very last page of your booklet, page 168, has I've modified their project into ours. All right? So if you're not sure exactly what we're looking for something like that, but with a lot more imagination. All right. That should take you to the point where I get back on the 17th of December, and I want you to work as hard as you can at this to get it done, and then I would like this to be close to done by the 17th, but your due date is the 19th. Right? It needs to be handed in by the 19th. All right. Good luck, and I'll see you when I get back. And if you get done this early, good for you. And like I say, I'll see you on the 17th bright and early.